Hi everyone, I'm from SK Engineering Limited. Welcome to this demonstration of the Spectrum Pipelines suite of software. Spectrum Pipelines is a set of modules of design and integrity calculations for onshore and subsea pipelines. The software suite comprises 13 different modules, and each module is dedicated to different aspects of pipeline design. Today, I would like to give you a tour of the on-bottom stability module, which is used for on-bottom stability assessment of subsea pipelines in accordance with DNV-GL RPF109. The module is activated by double-clicking the application file, which loads all of the software features. The graphic user interface has a very simple and user-friendly layout, which assists users with entering the input data on screen. The user interface is divided into 3 screens. Pipeline and oceanographic input data are entered in the first screen. Geotechnical and other input data are entered in the second screen. The third screen displays the results of the absolute and generalized stability analysis performed in accordance with DNV-GL RPF109. Once the input data is inserted and the user hits the Calculate button, the software solver calculates for the required parameters and outputs the results on screen. To start, let's take a look at the first screen, which is divided into 2 main sections, which are the pipe and coating parameters and the oceanographic parameters such as seawater properties, wave and current properties, and marine growth properties, if applicable. The second screen is divided into 2 main sections, geotechnical data and other data. Geotechnical parameters include the soil type, which can either be sand or clay, seabed roughness, coefficient of friction, undrained shear strength, submerged weight of the soil, and the angle of friction in case of sand. The user also has an option to input initial penetration, if known. If, however, this parameter is not known, the user can leave this field empty, in which case the software will calculate the initial penetration. The user can also specify penetration due to pipe laying or due to pipe movement and the penetration pressure difference. In the Other Data section, the remaining parameters need to be entered. These include the pipeline condition, which could be empty, flooded, or operating, the trench depth, the angle of the trench wall to the horizontal plane, the safety factor, and the submerged weight to be used for the initial penetration calculation. The user also needs to specify whether the seabed is permeable and whether the pipeline is laid in a trench. Now let's take a look at the results screen. The results screen is divided into 2 main sections, which are the absolute stability assessment results and the generalized stability assessment results. The absolute stability results include the submerged weight required for absolute stability, the vertical and horizontal factors of safety for the pipeline, and confirmation of the pipeline passing or failing the absolute stability criteria. Results of the generalized stability assessment firstly provide verification that the generalized stability criteria are applicable to the pipeline. The results then show the submerged weight required to maintain the pipeline displacement between 0.5 and 10 times the pipe diameter and the related factor of safety for this range of movement. It then indicates whether the pipeline passes or fails the generalized stability criteria. The results also give an indication of whether the flow regime is wave or current dominant, and provides the specific gravity of the pipeline in empty, flooded, and operating conditions. The result sheet, as well as a summary of the input parameters, can be saved as a PDF file. Each project case can be saved and reloaded for editing in the future. Thanks for watching this demonstration of the Spectrum Pipelines on-bottom stability module. For demonstration videos of other modules, please get in touch with us at info@engineeringsk.com or inquiries@z-subsea.com. Spectrum Pipelines. making pipeline design and integrity smarter.